an honor for me to host you all here. I met some students from India last night, as you have seen in the WhatsApp group, and they have traveled 3 days to come here, like 1 day by bus or train and 2 days flying. So thank you very much for coming. Other people did not travel so much, but all of you traveled a lot to come here, so it's a real pleasure. The main objective of the school is to set up a network. So from now on, you're part of our network of PhD students and future glass researchers. I'm sure in a few years I'll meet you in different conferences and say, hey, we met in São Carlos when you were a student, now you're a famous researcher, and we are here. I'm telling, this is not a prediction, this is a fact, because we organized the previous school in 2015, and I still meet several of the students of the 2015 school everywhere, and they keep in touch. So networking is a very, very important thing. There are other objectives, but before I spend too much, I'd like to introduce Professor Osvaldo. Professor Osvaldo is the director of this institute. This is considered one of the 2 or 3 best institutes of physics in Brazil and in South America, the University of São Paulo. He is the director, and he offered this marvelous theater for us. So Professor Osvaldo, thank you so much for offering your facilities to us.
So thank you very much, Edgar. So just a few words of welcome. So first of all, especially for our international guests, so I hope you enjoy your time with us in Brazil, and I also hope that you have some time to visit our institute. Our institute is quite peculiar, because even though it's a physics institute, we have research in many different areas, including areas related to health. So we do a lot in terms of technology for health. And I think you came to the right place for a meeting like this. Because one of the things that people ask me when I give a lecture is, what do you see in the future for us, the young guys, with so many changes that is occurring? And now that we know that very soon we'll have machines doing most of the intellectual tasks, so what's left for us humans, or the researchers, the human researchers? And one of the things which is left for us is work on materials, glasses and other materials, because the machines need these materials to do their computation. That's one thing. The second thing is that what sort of background scientists will need in, say, 10 or 15 years. They will obviously need the background in their specific fields, so engineering, physics, or chemistry, but they also need to work in groups, in teams. So networking, as Professor Edgar Zanotto mentioned, is going to be a crucial thing in the future. And some of the soft skills which will be required for a successful career in the future involve the ability not only to network, but work together, work in cooperation, work in collaboration, and being able to see what machines cannot see. And that's something which is an important thing. So I do hope you have a tremendous time with us here, and that you, in addition to doing a little bit of study, research, and science, you also enjoy yourselves and enjoy each other's company. And I really wish a very successful event for you. Thank you very much.
Obrigado. Okay, let me briefly go over the program especially for today and then some minor changes that we had. As you know, you have the fire talks now, this morning, and the objective of the fire talk is to advertise your posters, just to advertise your posters. So you bring people's attention to your posters, and the posters will be standing downstairs at the coffee break area for 2.5 days. So be the whole day today, tomorrow, and Wednesday until lunchtime. So the idea is that if somebody's interested in your particular research, you have time enough during the coffee breaks to show up and discuss the posters. The other idea is that you introduce yourselves. That's why we have organized the posters for the very first day, so we know who you are. And then start to collaborate. That's the whole meaning of this school. Start to collaborate, and this is the nucleation stage, this morning, the nucleation stage. Also, some people are registered for the postgraduate program. We have a postgraduate program, as you know, and if you're going to get credits, there are about 15 people who are registered. This is part of your evaluation already. Some professors are here to take notes of your presentation. So every presentation is important. And this is part of your training also. To be able to deliver a lecture, it's very important for a scientific career. So registered students, pay attention because you'll be evaluated today already. This is good news, right? In addition to the posters, after the posters, we start the fire talks, we start the poster presentations. And then, and I have, you please stand here. And I should ask you this. This is going on live on YouTube. Good news, right? Good news. If you're really against it, okay, you cannot present your fire talk. If you, for some reason, if you have a very, hot topic that you don't want to advertise to the whole world, then okay, you feel free and do not present your fire talk. But if you agree with that, you'll be, online to the world. That's also valid for the professors who will be giving lectures. If you do not want your lecture to be live, so let us know. So I'll tell to our TI guy that your talk will not be recorded. So for the fire talks, okay? Everybody okay? Yeah. Everybody happy. You'll be on live today. So please start to, advertise to your Facebook or Instagram or LinkedIn that you'll be on live to your mothers. Then poster presentations, and then we have lunch. And the local students, there are several local students. Please guide our guests. It's walking distance, like 3 blocks from here. There are plenty of restaurants, and there are some in Brazil. There is a per kilo restaurant, so you get everything you want, and then you pay depending on how much grams or kilograms you are going to eat. And there are 3 of these walking distance from here. The best one is called Manhã Natureza. This is the very best, right? Manhã Natureza is really good, but it's fully packed. You have to wait a little bit normally. There are another one called Frei Damião, and there is a São Carlos Club restaurant, Cardal. There are 3 decent restaurants. And there are several other, smaller restaurants also. But the local guys will guide you to the restaurants. I'll be joining you also to one of these restaurants. And then Professor Helmut Eckert, who is here. He had a minor accident, but he has kind enough to still come here and give his lecture on EPR. And then Marcos Oliveira, Professor Marcos, who is here also, will give a talk on NMR. And Marcos, we discussed a little bit, if you could compress a little bit your lecture, because just right after the lecture, you have to walk back, at least those who travel to São Carlos, walk back to your hotel. There'll be a bus waiting for you. And there are only 45 seats in the bus, so we reserve the bus for the people who travel to São Carlos. The local guys, there is Uber, there is cars and everything. You go by yourselves. And because of the traffic, this is 5:30 in the evening, there's lots of traffic. It's rush hour. It will take at least half an hour to reach the cocktail place. Is the innovation. Park Tech is the innovation incubator of high-tech companies. And they offered this space to us. It's an interesting space outside town for our cocktail. And of course, there are drinks, etc., but we have class tomorrow morning at 8 o'clock. So, one drink is okay, not too many drinks, please. Otherwise, there will be not many people here tomorrow. Okay. Then there's a small change. Dr. Il Kais from CICEJAM, who is giving a talk on innovation at CICEJAM, is one of the largest glass companies in the planet, has moved from Wednesday to Thursday. And this is the only change, I think, so far we have in the program. And then, tomorrow night, I have asked you to bring delicacies from your countries. So please bring them tomorrow in the afternoon or tomorrow here. So right after the talks, we'll have this exchange of foods from different countries. I'm sure there will be plenty of food. If 80% of you brought something, there will be enough for 2 or 3 days, I think. But we can taste different delicacies tomorrow. Then, for the guided tour, a lot of people signed for the Santa Maria farm. We have a bus for you. We'll depart from the hotel again. And I think 2 or 3 people signed for the zoo. Ricardo, are you going to take care of this? So Ricardo will take care of the zoo guys by car, right? It's only three people to the zoo, which is interesting. There are Brazilian animals that you have never seen elsewhere, I think. And then you have a night free. Wednesday is free. And then everything is self-explanatory. On the last day, there'll be a bus departing early from your hotel to the campus 2. There are 2 campi of the University of São Paulo. Professor Eduardo Bellini here will host you at the campus 2 of USP, where several of the glass labs are. And then you come back here and visit the NMR and glass labs here at the Institute. And then you're free to go, and the conference will change. If there are any other changes, I'll let you know. But this is more or less what I like to say today. And now we start immediately to the fire talks. So, dear Henrik, where are you? Yeah, please. You'll be our local guy here to help us. quando chegar no comprimido, aí vai um por um. Né? Ou você pode... Você passa todos individuais. E depois, quando chegar lá, abre, né? É isso? Não, esquecer. Ah, ela botou individualmente, então. 40, então tá faltando um. Não, faz assim. Você abre, eu vejo quem é e chamo. Tá? Então você abriu um. Well, we start with Adam, please. Alphabetical order. Adam.
Yeah.
Okay, counting.
Hi, everybody. I'm Adam Shear. I actually have a slide to introduce myself. So I'm originally from Corning, New York, where Corning Incorporated is, a big glass company. But I did my undergraduate at Alfred University, and now I'm doing my PhD under Dr. Morrow at Penn State in material science. The overarching theme of my work is infrared transparent oxide glasses, and mostly I've been focusing on vanadate glasses. So I've been building a topological constraint model to look at barium vanadates and other alkaline earth vanadate glasses. So here I show a figure that we can use to predict glass transition temperature as we change the modifier content in these vanadate glasses. And this is also applied to hardness and elastic moduli. Also, I have been studying the electronic transport properties and also dielectric and dielectric loss of these glasses. So in the bottom left, we can see that as strontium oxide and barium oxide are added to these vanadate glasses, the dielectric constant decreases along with the dielectric loss. Essentially, the vanadium oxide concentration is directly proportional to these. And you can see with the electronic transport that the activation energy is quite low for electric conductivity, meaning that these glasses are potentially can be applied for semiconductor applications. And in order to keep this short, that's pretty much all I had for today.
Very good. Thank you. Albert, from my own group.
Good morning, everyone. I'm Albert. I'm a student of LAMAVE. My supervisor is Professor Edgar Zanotto. And thank you, Professor. And my work is intitulated Dynamical Process in Silicate Glass, Buried Silicate Glass, Structural Relaxation, Nucleation, and Crystal Growth. My first result about the isothermal heat treatments showed that the crystal nucleation rates below the glass transition temperature need more time enough to reach the nucleation ultimate steady state. As we can see here, the graph, the figure at the right. The next one result about the crystal growth showed below the induction time for crystal growth, another slope is verified. Thank you, Professor. And as we can see here, this graphic and the red points. And another slope is verified. Probably another mechanism diffusion is occur in this region. Finally, as you can see here, that finally the final result showed that isothermal and non-isothermal heat treatments can be used to measure the activation energy. In this case, non-isothermal method is used, DSC method, and the model Kissinger equation is used to demonstrate the same activation energy can be measured, as we can see here. To more details, we invite everyone to see in our poster. Thanks for your kind attention.
Next up, Amir.
Amir.
Hi everyone, it's Amir Ashjai. I'm from Alfred University, New York, US, originally from Iran. I have my bachelor and master's in ceramics engineering in Iran University of Science and Technology. And now I'm a glass science PhD student at Alfred University. And I'm working on the thermal, structural, and optical properties of boroaluminosilicate glasses and glass ceramics. In Alfred, I'm working in Dr. Monke's group, and in there, our approach is actually finding the correlation between structure and properties of the glass through spectroscopic techniques. And then mostly I'm focused on borosilicates and aluminoborosilikates, specifically aluminoborosilicate glass ceramics containing indium tin oxide nanocrystals to develop materials that are transparent in visible region, but highly UV and near-infrared shielding properties. Nowadays, I'm mostly focused on linear and also nonlinear optical properties of these glass ceramics, and also I'm trying to understand as much as I can the structure and crystallization mechanism in these glasses through Raman and NMR techniques. And then the questions that I'm dealing with is right now, what's the role of indium oxide in these glasses, which I think I get the answer recently. How I can improve the homogeneity of these glasses, which are high viscosity, high temperature glasses, and also what's the exact crystallization mechanism of ITO nanocrystals. Thank you.
Next up, Anna Caroline.
Hi everyone, I'm Anna. I'm a PhD student in the Department of Engineering, Materials Engineering at the University of São Paulo. My advisor is Professor Eduardo Bellini, and my research project is about additive manufacture of glass and glass ceramics. I especially work with the digital light processing technique, how you can see in the animation in the left side. But for that, we need to prepare a suspension. But before we just printing any glass or glass ceramics components, we need to study the rheological behavior of the suspension, for example, viscosity and stability, because the suspension needs to meet some requirements for a successful 3D printing process. So if you get interested to know more about the rheological behavior of the diopside glass-based suspension and some sintering tests that I made, I invite all of you to come to my poster, and I will be glad to share further information with you. Thanks for your attention.
All right, Andrea. Andrea here? Okay, but everyone has seen her, if this is her. Next is Anthony. Edgar, where's the laser pointer? Edgar, do you have the laser pointer? And maybe if you want to use that to skip the slide. All right, stage.
Thank you. Hello, my name is Anthony Sukrikas Jr. I'm a PhD student at Lehigh University under the advisement of Dr. Himanshu Jain and Volkmar Dirov. And the work that my group primarily focuses on is the femtosecond laser irradiation of different glass structures. For my work, I work with lanthanum borogermanate glass. And what we're able to do is with the femtosecond laser, by focusing it in the glass, we can create these line modifications. And the two modifications we make are single crystal lanthanum borogermanate, and the work that I'm working towards is creating a continuous channel of germanium nanoparticles. And the goal is to combine these two components, both electrical and optical, to create new photonic-based devices. Yeah, I'll just do this. So trying to identify germanium nanoparticles in my glass is rather difficult because my modifications are so small, but we're able to use Raman spectroscopy to be able to identify the relative location of the nanoparticles. And we'll have a distinct peak that forms in the glass that we use to create the different maps. And another interesting note that we see when we make these modifications is that peak of germanium nanoparticles will shift And based on Raman spectroscopy and the phonon confinement model, that indicates that the nanoparticles are changing in size. So that gives us promise to be able to better control the size of the nanoparticles to try to make a more continuous channel of them. And so you can see in the bottom right figure, we're looking at along the length of the line, and we're almost continuous. So we're very thoughtful of the what we'll be able to achieve. With that, thank you.
All right, Ashutosh. Good. If you need a laser pointer, you can use this button, but maybe just skip the slides with the Arabic.
Yes, so good morning, everyone. So I am Ashutosh Ujjwal from Indian Institute of Science, Bengaluru, and I am a second year PhD student there under Professor K. Ramesh. So I have just started my work. So so I have made this ASSC based glasses, and I am trying to study how the change in composition, variation in composition is affecting the various properties like density and glass transition temperature, and like this. And then we know that this glass transition temperature has also relation with the viscosity, or we say fragility. So in order to get an idea of how fragile my glass is, we have done this differential scanning calorimetry at different heating rates, and then try to find out the fragility index for that. And lastly, in order to get an idea of a structure, I have tried to do this pair distribution function analysis, so that I can know that how the changing composition is changing the structure, and which is in turn determining the properties of my glass. So this all I will try to discuss in my poster. Thank you for your attention.
Badar, I think pronounce it.
Good morning, everyone. My name is Badr Khan. I am a first-year PhD student at FunGlass under the supervision of Associate Professor Jose and Master Gustavo Gilani. My PhD topic is nano microstructure fluoride-based luminescent material for non-contact optical thermometry application. The main objective of my topic is to preparation of a triply doped oxyfluoride glass and glass ceramics, and to study their structural, morphological, and spectroscopical properties. And at the end, building a prototype for temperature sensing utilizing our glass ceramics. My research focus area will be on ratiometric thermometry technique, which is based on fluorescent intensity ratio of two thermally coupled and non-thermally coupled energy level, and to focus on the possible crystallization mechanism within a glass ceramics. The key activities include the preparation of the material and focusing the relationship between these processing parameters, and characterization by different methods. The significance of this research is to develop a prototype for a rapid response, accuracy, resolution, and reliability. Here is I have selected the aluminosilicate oxyfluoride glass ceramics, and the doping elements are erbium, thulium, and ytterbium, and this is showing the possible energy transfer between the mechanism. Ytterbium will act as a sensitizer to have some upconversion luminescence properties. Thank you so much.
Oh, next up, Kaner. There you go. Just give the arrow, please.
Okay. Hi, I am Caner Aslan. I am from Turkey. I work in Şecam Science and Technology Center as a researcher, and I am also a PhD student in Istanbul Technical University. In my thesis, I plan to investigate using borate bioactive glasses for osteochondral tissue regeneration. Osteochondral tissue is found on synovial joints in human body, and it consists of both cartilage part and a subchondral bone part, and their chemical, biological, and physical properties are different. So I want to investigate using copper, manganese, and zinc doping on borate bioactive glasses for osteochondral tissue regeneration. And I am waiting to meet you on poster session for details. Thank you very much.
Carlos Monroe.
Good morning. My name is Carlos Monroe. I'm from the Federal Institute of Maranhão. The title of my work is Glass and Glass Ceramics for Sealants in Solid Oxide Fuel Cells. The objective is to investigate the effect of zinc oxide in the structure, thermal properties, sinter, and crystallization kinetics in some glass and glass ceramics of the calcium, strontium, boron, and silicon system. Some requirements are necessary, such as a coefficient of thermal expansion and good sinterability with values higher than 25 Celsius degrees. The research is ongoing, and I have some results from GSC and HSM. We've demonstrated good sinterability in Z4 and ZH glass. Thank you.
Carsten.
Bonjour and good morning, everyone. My name is Carsten Blaise. I'm a postdoc researcher already, somewhere between the Federal Institute of Material Research and Testing in Berlin and IFSC, I hope. And I dealt with a lot of different topics in my scientific life up to now, and will be still interested in any discussions, so feel free to discuss anything of these topics with me, about starting from glass synthesized powder processing. One of my big focuses is on sintering, foaming, and then of course nucleation, crystallization with the focus on bioactive glasses. Oh, there's an image missing. And 3D printing, so if you need a bone or a brain, it's possible. And one more exotic topic, maybe you less heard about, crack growth you heard maybe, is the crack healing. I did my PhD on, so I would be very happy to discuss, learn more here on this school, and thank you.
Yeah, okay. Next subject. Skip with the arrows.
Hello, I'm Chirag from IIT Mandi, India. And apart from all of you, like I work in the catalytic activity of this glass ceramics. Especially we are using powders, ferroelectric materials, and I'm trying to embed this ferroelectric material inside glass and make it glass ceramics for water cleaning applications. So like there is no explanation needed why water is necessary, and like there are many industries which are polluting our water itself, like textile industries using dyes for coloring our garments and then discharging it into rivers. So I'm trying to sort this out with the help of glass ceramics. So glass ceramics, especially ferroelectric materials using pyro, piezo, and dielectric properties of ferroelectric ceramics, like they are non-linear optical properties, they are very good, famous for, and they have a hysteresis loop of the polarization that it varies with electrical potential. And as you can see in the picture, there's a powder ferroelectrics, and it's very hard to recover and reuse once you use this catalyst for water cleaning applications. So I'm trying to embed this into the glass and make it glass ceramics. In the next picture is transparent bored glass ceramics. And one of the main thing we are trying to do is crystallize it with laser source and try to have a crystal, like oriented crystal or somewhat control over the grain structure, and the corresponding thermal images and the same image of the same. And the second one is a laser crystallized glass sample. First is the transparent normal S-quench sample. And yeah, we use for water cleaning as well as antibacterial applications. So we have degraded some of the gram-positive negative bacteria with this piezoelectric property of the glass ceramics, as well as after the purification of this water, we have used for a seed germination to see if it's actual work or not. And yeah, we use the photocatalysis and piezocatalysis, one of the two major catalytic processes. Yeah, so this is all about my work. Thank you.
Okay, people start to read the order of we have here, so makes my task easier.
Good morning. First, I want to add that I'm very happy to be here. I think it's a great occasion. And the topic I want to present you is about a fully automated system for the development of glass installed in our lab. Is it not? Okay. I want to present a topic about a system installed at our lab for the fully automated development of glass. This is done at the German Federal Institute for Materials Research and Testing in Berlin. We have about 1,500 employees, and I'm one of them at the level of an engineer. On that image, you can see the device I'm talking about. At the core working is a standard industrial robot. The whole system was invented by the Institute for Silicate Research of the Fraunhofer Society, also in Germany, and then installed in our lab. In our terms, this is the glass screening device because it is used for the automated development of glass throughout the compositional space of oxide glasses with individual recipes. The challenge, however, is to translate the manual melting cycle to an automated one using a choreography of different steps and devices, such as there are a balance for the raw material mixture, a step for homogenization, another balance, this one a heat-proof one, where the crucibles are filled, which are then transferred into one of 3 melting furnaces. And molding is also something quite easy for us humans, but for a robot it's a little bit more tricky. And then to the end, of course, you need a good annealing step to achieve a nicely formed block of glass, as you can see here. With many thanks to my supervisors and colleagues from Berlin, and thank you. See you.
Feel free to adjust the speak loud.
Hello, everyone. I'm Cristina from the University of North Texas. I'm from Mexico. Nowadays, I am working with glass, ceramics, and ceramics to develop new generation of solid-state electrolyte. I am part of the group of Dr. Jin Chen-Tu, who visited this university some years ago. Nowadays, we are working with fluorine doping to develop a new generation of solid-state electrolyte. We are focused in improve the ion conductivity and also to understand the fluorine doping. I hope you will be more interested about this, and I will explain you in the poster presentation.
Daniel? Ok. Sim, mas como abre no tela cheia? Tela cheia. How do we get full screen on this thing? F12? No, not in F11. It's all right. You manage.
Good morning for everyone. My name is Daniel. I am a doctoral student from Institute of Chemistry of São Paulo, here in campus. I am a member of Laboratory of Inorganic and Materials in vitro materials. With my advisor is Professor Danilo Manzani. Talking a little about my research, I work with bismuth phosphate glasses with high content of bismuth and study how the bismuth acts in the glass matrix and in his influence in structural, optical, and thermal properties. Studying by Raman and NMR's techniques. And I also studied how the compositions and systems parameters affect the properties of the materials when they are doped with earth elements like europium. And once we have the better understanding of this glass system, we can adjust the parameters to have suitable properties for opticals and photonic applications. As for example, the oxidation stage of the bismuth glass, as we can see here, just to adjust the better properties like the refractive index and the color of the glass. Here's a picture of the group, my contact, and thank you very much for your attention.
All right, Dimit.
Hello everyone, I'm Demet Aydomuş and I came from Turkey, Istanbul Technical University. Actually, I got my PhD degree about 3 weeks ago, and my doctoral thesis is about production and development of alloy ceramics via a reactive SPS process. Actually, I have a brief information about the transparency of polycrystalline ceramics because it's related, directly related with the microstructure, and you have some boundary conditions. You need to get a highly dense structure without any internal stress or any secondary phases or impurities. So there are some unique properties of alloy ceramics summarized in this table, and due to its excellent transparency and mechanical properties, they have been used in many military applications or also commercial applications. And alloy production is an energy-consuming process, so spark plasma sintering is an effective way to get high, dense, and transparent alloy ceramics in a shorter time and lower sintering temperature. But the main challenge is the carbon contamination due to the graphite equipment in the SPS system. So we have a recent publication about the carbon contamination, prevention of the carbon contamination of the produced alloy samples. So if you have any questions, which I have included the highlights of my thesis study in the poster presentation, and I am happy to be here. And I will intend to work on glass ceramics on my postdoctoral studies. Thank you very much.
Okay, next up, Evaldo.
Hello, good morning. My name is Evaldo Hofman. I'm graduating in material engineering, and now I'm student in master degree in LAMAV. My advisor, Ana Cândida. Firstly, I'm Desire, welcome to Glass School, and everyone very happy to receive you. And about me, I'm graduating in 2023, and I'm work at aluminum alloys and hydrogen production. And now I'm starting to work at glass and vitro-cerâmicas, specifically Nazicon families, and they use in the materials fly sinter for the crystallization. And in the future, I do to the PhD, and that's all. Thanks, my contacts, and scanning. Thanks.
Giovana. Lead us in there.
Sorry. Good morning, everyone. My name is Giovanna Lira. I'm a PhD candidate in Material Science and Engineering at Federal University of São Carlos. My supervisor is the Professor Edgar Zanotto. And currently I'm working with transparent lithium disilicate glass ceramics stranded by ion exchange. As you can see in this figure, ion exchange is a very useful technique for improving the mechanical properties of glass or glass ceramics. It's used in a famous Gorilla Glass for improving mechanical properties of this material. And this process involves the exchange of small ions from the glass surface or glass ceramic surface with the larger ones from the mold salt bed. And the difference between the ion size results in a residual compressive stress on the glass or glass ceramic surface, and this residual stress enhance the mechanical properties in these materials. So this is my thesis subject. In addition of this line of research, I'm working with bioactive glasses and composites, as you can see here. I will talk a little more about this topic on the Friday morning. But I'm working with development of magnetic composite for bone cancer treatment by magnetic hyperthermy. And I'm working with development the transparent glass ceramics with different crystallized diffraction. So I hope we can enjoy this event, and I'm available for future collaboration. Thank you.
Guilherme, thanks.
Good morning, everyone. I'm Guilherme Lenz, a chemistry PhD student from University of São Paulo, and I'm talk a little bit about my PhD project. Is the development of transition metal nanoparticles on oxide glasses for heterogeneous catalysis. So this is my group, my research group, and this is my advisor, Professor Danilo Manzani. So basically, I'm working with copper nanoparticles, but I can grow these nanoparticles on an oxide glass surface. So basically, copper is just like a normal glass modifier, but when we thermally treat this glass on a hydrogen surface, we can grow these nanoparticles, and if we desire to oxidize these copper nanoparticles also. And in my poster, I will present some results about the mechanism of growth, these nanoparticles, by in situ X-ray absorption. Basically, we need to understand how is this growth mechanism and how the glass composition affects this process, and then develop more efficient heterogeneous catalysts, like for glass pellets that I'm working in my PhD thesis, to maintain oxidation in hydrogen peroxide. So thank you everyone for your attention.
The next Guilherme.
Good morning, everyone. My name is Guilherme. I'm a master's physics student from UFSC, and my work is a study of structural and optical properties of telluride glasses doped with neodymium. To start, the importance of this work is to reach the world goals. Those goals being goals that try to improve the world as a whole. Those can be health goals, material goals, or anything. And my work is a target 9.8 that tries to make accessible and cheaper material to all the world and all the peoples. In this work, I try to use, as I said, telluride glasses doped with neodymium. These telluride glasses already know about a vast amount of applications, being dental, chirurgical, tattoo removal lasers, and in the point of neodymium itself, is already known by the literature that increases the laser efficiency and the quantum efficiency of those lasers. Also, neodymium is vastly using magnets, LEDs, etc., etc. Those are my samples, and those are the concentration of the samples that I used. The techniques I used were to study, again, physical, structural, and optical properties of those glasses. As you can see in the Raman graph up there, we see that the neodymium had little change in the structure, up in little concentrations. And in the optical properties by the band gap, we see that the best fit was by the m equal 3. And that can, if this work proves fruitful, can mean that we may have a new superconduct in our hands. Thank you very much.
Qualquer coisa a gente descobre na hora. Jacob. Okay, 2 slides. Okay. If you want to use the presenter, otherwise just. Which one is the laser? I think it's. Check if it works. Yeah.
Hello, good morning, everyone. My name is Jacob Lovey. I am a student at the University of California at Davis, currently completing my master's degree, and I study under Dr. Sabisashi Sen. So the project I'm going to be talking about today, one of a couple, is the effects of isotopic substitution on shear relaxation in B2O3 liquids. There. So we are looking at the isotope effect in these B2O3 liquids, substituting just the boron isotope for a slightly heavier one. We take the approach of using, there it is, isotope effect parameter, and we substitute diffusion or diffusivity for viscosity via the Stokes-Einstein, the fractional Stokes-Einstein relation. So what we find here, I'm showing my viscosity data, where we find that at near TG, we find slight deviation or separation, which validates the elastic models of viscous flow, and we're able to attribute this to the higher zero-point vibrational energy and the attempt frequency for viscous flow. Looking forward to meeting you all, and yeah, thank you.
Skip. Laureano.
Hi everyone, good morning. The main goal, one of the main goals of this work is to understand the structural role of intermediate oxide in glass, especially the structural role of niobium in phosphate glass. For that, we use Raman zone spectroscopic techniques like Raman, solid-state NMR, along with the use of computational modeling. In order to shed light on that, we synthesize and characterize a simple niobium phosphate glass in which all the nucleus are NMR updated. Because of that, we can do simple and double resonance technique in order to get insight about the structural role of this particular intermediate oxide. So my name is Laureano Suncho. This work is overseen by Professor Helmut Ecker. And if you want to know more about that, so go to my poster. Thank you.
Leonardo Barbosa. PDF or presentation?
Bom dia, good morning, everyone. So my name is Leonardo. I am a PhD candidate in material science and engineering at the Federal University of São Carlos, so UFSCar. So just a little bit about me. I'm 30 years old. I'm actually from Campinas, but I'm living here in São Carlos since 2012 when I came here to do my undergraduate course in materials engineering. And in the free time, when I have some, I like to read, learn English and German, visit waterfalls. There are quite a few here near São Carlos, and hang out with friends and watch movies and series with my girlfriend and my children. My education, I did a bachelor degree in materials engineering, a master's degree in materials science and engineering, and now my PhD in materials science and engineering. So my research project, I'm doing with the Professor Murilo Crovassi as advisor and Professor Ligiane Costa as co-advisor. And I'm trying to develop polycaprolactone-based composites with Bioglass 45S5 through additive manufacturing, the selective laser sintering technique, and in order to develop scaffolds for bone tissue engineering. And I still don't have many results, but I will be very happy to share with you some of my work and what I have studied so far. Thank you.
Next, Leonardo. Se for usar isso, mira para cá. Se não usa a seta. Se for usar o apresentador, mira para aquele receptor aqui. Ou se você usar a seta aqui.
Hello, hello. Hello, everyone. Good morning. My name is Leonardo. I'm Brazilian, originally from the north of Brazil, a state called Amapá, and a state called Macapá. And welcome to the second São Carlos School in Glass and Glass Ceramics. I will present for you later my master's project called where I use a artificial intelligence model to predict some glass properties. I will have to share with you the results of this project later in my poster's presentation. Thank you.
Lucas.
Good morning, everyone. It's very gratifying for me to be with you today at this event. My name is Lucas do Carmo. I'm a master's degree student at PPG-100 UFSCar, and my advisor is the Professor Murilo Crovassi. We are members of Bioactive Materials Laboratory, where we research about bioglasses and bioactive glass ceramics for tissue engineering. My current theme is stabilization biosilicate-based stabilization of biosilicate-based aqueous suspensions. Thank you.
Okay, good morning, everyone. I'm Elena. I'm a postdoctoral researcher at the Vitreous Materials Laboratory La Math here in Brazil. Currently, I'm participating in several ongoing studies that can be divided into 3 topics. Basically, fundamentals of the vitreous state, properties of glasses and glass ceramics, particularly mechanical and optical properties, and bioglasses. So, as particular examples of each one of these topics, I would like to mention this study on the left, in which we found that the effective diffusion coefficient for crystal nucleation is best estimated from crystal growth rate data than from viscosity. And this is important because can allow us to give a better description of the nucleation process through some models or theories, such as the classical nucleation theory. For the second topic, this study, we aim to develop glasses and glass ceramics, combining 2 normally antagonic properties in this kind of materials, such as transparency and good mechanical properties in general. And for the last topic, we aim to develop some wound pads from glass fibers. And in this case, we are using the salt gel route to fabricate these glasses and the centrifugal and electrospinning techniques to fabricate the fibers in general. So that's it. Welcome to the visitors. It will be a pleasure to meet you all during this week and to have fruitful discussions with all of you. Thank you so much.
Masud.
Hello, everyone. My name is Masud Ospuri from the University of Miskolc, located in Hungary. And I'm working on performance of foam glass granules in lightweight concretes. But what is foam glass? Foam glass is a porous material that is very lightweight, and the main structure of that contains glass. So I'm using foam glass to make lightweight concretes. The main innovation in my project was to make granular shape of foam glass and use as aggregate in concrete. In my project, I used Taguchi design of experiments to diminish the required number of tests. So I could decrease the number from, for example, 100 required tests to 27 of them and predict the others. Foam glass has some problems to use in concrete. The first one is it's not strong enough to use in concrete and make a structural concrete. And the second one is alkali-silica reaction that takes place between foam glass because of its amorphous nature and the cement mortar. So I'm here to learn how to make foam glass relax, to increase the strength of that, and how to crystallize it to avoid alkali-silica reaction between cement and foam glass granules. Thank you very much.
sabem. Se quiser usar apresentador, qualquer coisa, só usa a seta preta.
Good morning. My name is Matheus José. I'm finishing my degree here at this university, and I'm doing my scientific initiation with my advisor, José Schneider, and for almost 2 years and a half, and we are researching about synthesis and characterizations of phosphate glasses with alkaline and alkaline earth ions. So in order to develop solid-state batteries, we know that phosphate glasses are good candidates for this, and we studied 2 series of them with mixed phosphate glasses with lithium incorporation and the other 2 ions, calcium and sodium. And we synthesize them in our lab through the melt quench technique and analyze through the densimetry, calorimetry, and NMR techniques. And we are concentrating our study in the vitrification through the planetary ball milling. That is a cheaper method and less complex than the roller quench, the usual methods that we use. And we already have some results for lithium metaphosphates, and we are trying now for the lithium calcium metaphosphate. And if you want to know more about it, you can call me in the poster section. Thank you.
Natalia. If you want to use the presenter.
Good morning, everyone. It's very lovely to be here in Brazil. My name is Natalia, and today I would like to give you a little sneak peek into the future of additive manufacturing techniques, presenting you with a novel technique for 3D printing of glass. So, as I'm sure I don't have to explain to this particular audience, you are all very well aware that glass manufacturing today comes with many drawbacks. First and foremost, vast majority of energy that is put into the system actually goes to waste. Then only quite simple forms and designs are attainable, and post-processing, such as etching or molding, is usually required. All of this combined makes glass manufacturing today not only costly, but very time-consuming process. But hey, we have found an alternative. I present you the Nobula glass 3D printer that utilizes the direct glass laser deposition technique to melt a very thin filament of glass up to 2,000 degrees, and so that we can deposit glass in a layer-by-layer manner into any shape and form that you can think of. So glass processing is now easier than ever. We can process glass using non-contact laser heating and produce elaborate designs of very high resolution, and no post-processing is actually required. But most importantly, it's insanely cool, and you can do it from home. And of course, we are still in the development stages of our system. However, we have already identified an array of potential applications for our products and systems. However, we are optimistic there are many, many more to come. So I'll be very happy to discuss this work in more detail at my poster, and thank you very much for your attention.
Patrick. All right.
Good morning and welcome everybody. First of all, I'd like to thank SATEF and the USP to be here to organize this. And I'm Patrick. I come from the German Federal Research Institute of Materials Research and Testing, and I'm at the group of Professor de Camargo. Today I'd like to talk a little bit about gaseous hydrogen storages for aviation applications and why we should use glasses, or why we could use glasses, therefore. Right now, you can see on the left, there are the common polymers that are used for gaseous hydrogen storage applications right now. And glasses are 3 to 7 orders of magnitude better in preventing hydrogen to escape such storage device. On the right-hand side, you can see already 1 micrometer thick layer of glass could theoretically increase the storage time drastically in the solid lines compared to the dashed ones. By using glasses, we could also simply reduce the weight of such a device, which is crucial for aviation applications. And we are flexible in the design for the airplane. So we could tune our storage device to the space that we have in a possible airplane application. For this, I'd like to thank you and wish you all a great week. Muito obrigado.
Yeah. Okay. If you want to use the presenter, make sure you aim it at the receiver. Otherwise, you can just use the other.
Good morning, everyone. Myself, Pritha. I am from India, from Central Glass and Ceramic Research Institute. I am a PhD student, and I am working on structural and spectroscopic property of telluride glass, which is a non-conventional glassy matrix with extended transmission window up to 6.5 micron. There are many photonic applications in advanced photonic application. We have published a review article on different photonic application of telluride glass ceramics. And out of all other telluride glassy matrix, I particularly choose to work with lanthanide telluride matrix. And we have doped more than half of the rare earth series from cerium to dysprosium and checked the effect of different rare earths ionic radii on crystallization mechanism and transparency retention of the glass ceramics. And here we came up with a very interesting fact that rare earth hole pair, which has a electronic configuration of 4f-in and 14-in, they exhibit the identical crystallization mechanism as well as the same result in transparency retention. Now, we have also doped the europium, which is a commonly known spectroscopic probe, and with the help of europium, we have studied the anti-glass phase precipitated in our glass ceramics, which is turned out to be C2V. And not only the ionic radii effect, we have also studied the effect of rare earth ionic radii in controlling the transparency of the glass ceramics and found that with increasing the rare earth concentration, it helped in retaining the transparency. And currently, I am also working with third order nonlinear optical properties of telluride glass ceramics, which exhibit at least 10 to the power 3 times higher nonlinear absorption coefficient compared to the commercial nonlinear optical material or fused silica, and it can be used as the optical limiting material with low radiation threshold. And my future objective is to prepare ultra transparent glass ceramics, which has completely identical transparency similar to its glass, and also examining the third order nonlinear optical properties of metal nanoparticle containing glass. And that's all. Thank you.
Rafaeli. Ok.
Good morning. My name is Rafael Peric. I am a master degree student at the State University of Ponta Grossa. My advisors are Francisco Serbena and Zanotto, and this work is entitled Fracture Restraint and Toughness of a Biosilicate Glass Ceramic. The biosilicate is a bioactive glass ceramic with application in dentistry, medicine, especially bone regeneration, and tissue engineering. The objective of this study is to elucidate the reason behind the observed small decrease in strain at higher percentage of the crystalline fraction, and to ascertain whether the variation in crystal size has a similar relationship for older glass ceramic, such as lithium silicate and barium silicate. Thanks.
Ricardo.
Good morning, everyone. My name is Ricardo, and I present you. I'm a PhD candidate here in University of São Paulo, and from glass synthesis to sensing. This work is divided in two parts. And then the first part, I studied processes for dehydration of telluride glasses and all structural changes and optical changes. And the second part, we use 3D printing for modifying surface tip of the optical fiber for printing sensor. And this is the resolution of the materials printed on the tip of the fiber. And if you want to know more about my work, you can come to my poster. Thank you.
Hi everyone, good morning. I'm Ricardo. I'm PhD candidate in the Professor Zanot's group. Yeah, I'm the guy who sends some message in the group sometimes. And I study glass relaxation and the influence on properties. So all glasses are unstable thermodynamically, so it relaxes to the supercooled state. And we see that measuring some properties. Here I'm showing some relaxation that happen over time when we put the glasses to relax in temperatures next to the glass transition, kind of below that, and we wait over time and see the properties changing until the stabilization. And the question is, what happened with the structure when it happened? So here is one possibility, that's the QN species changes, so the Q1, Q2 plus Q4 changes to Q3, and we can talk about it later during the post-presentation. And it's a pleasure to be here and meet all of you, and thank you very much.
So good morning, everyone. I'm Roger. I'm glad to share part of my postdoc journal at the new Brazilian synchrotron facility in Campinas. Campinas is just halfway between São Carlos and São Paulo. I'm currently working with persistent phosphorus embedded in glass matrix. And in order to understand a bit more about the mechanism behind the long afterglow of this phosphorus, and also the interaction between this phosphorus and the glass matrix. And how do we do that? Using synchrotron radiation-based techniques available at the Carnaúba beamline. Carnaúba, it's a acronym for Coherent X-ray nanoprobe beamline, and this beamline offers a beam resolution of about 200 nanometers. And this beamline, we have different detectors that allow us to perform different kind of experiments. For example, X-ray fluorescence image in a broad range of energy, and also X-ray excited optical luminescence, nanotomography, nanodiffraction, and so on. So if you are interested to know a little bit more about this class of materials, synchrotron radiation or synchrotron radiation-based techniques, you are more than welcome to my poster. Thank you.
Yeah, Roni. Good morning, my name is Roni. I am student material engineers. My project is a curve of lithium silicate glass and glass ceramic. My advisor is Francisco Cerbena and Renan Belli. My university is State University of Ponta Grossa. The project, and thanks. Victor, gonna skip one.
Hi everyone. I'm Victor. I recently got enrolled in a PhD program, so I'm going to present some previous work in the development of glass persistent composite by direct incorporation of this persistent luminescent that I'm gonna call PEL into phosphate glass. So why incorporate PELs? PELs are generally obtained in a powder format, so we need to incorporate it into a host matrix to be widely applied. And PELs are of interest because it's cool application in glow-in-the-dark toys, night signaling plates, and technological applications in bioimaging and road marking. We aim to incorporate it into a glass matrix. Therefore, there's challenges. Literature reports that using this incorporation method leads to glass crystallization interface and PEL particle solution, taking the luminescent properties. Considering all these problematics that you can see in my poster also, we synthesize a niobium phosphate soft glass matrix and propose a direct incorporation method modification to solve the PEL solution problem that you all gonna see in my poster. Come and see it, and thank you all.
Now, Vinicius. Você vai scrollar.
Okay. Good morning, everyone. I'm Vinicius. I'm a PhD student here in the University of São Paulo, and my research is the laser description of high optical contrast and photosensitive fluorophosphate glasses. Just a short introduction. We use the fluoride phosphate glasses because the combination of the optical properties and the spectroscopic properties, and we want to obtain a controlled structure inside the glass. And one of the options to make this is using the femtosecond direct laser right technique. The objectives for the work is use this composition and create the silver structures inside my glasses and evaluated the optical and spectroscopy properties and evaluated to the possibility of the energy transfer between the silver species and the neodymium. And the final of my work, the objective is evaluated the possibility to apply these glasses with the waveguides. This is previous results. It's possible to obtain my glasses with the optical transparency window. And in my glasses, before the laser descriptions, we already have some silver species in my glasses. And when I apply the direct laser, it's possible to write some structures with different intensity lasers and speeds. And these variations appear some different properties in terms of the spectroscopy and optical, the optical localizer properties. We have different, and we can see the positive variation and a negative variation in terms of the index modification. For more details, we can bring my poster and we can discuss and show the results. Thank you.
Hello, everyone. I'm Yara. I'm beginning my master's students now here at the Institute. And what I do in my work is I added gallium to the biosilicate composition, the bioglass. So for those who don't know, I think we talked about it a lot, actually. A bioglass is a glass that activates a biologic response. So it's good for implants, good for your dental implants also. And why add gallium here? Because of its antimicrobial potential. So we are trying to see if this could actually increase the performance of the glasses, since it can lead to more acceptance in the body and tackle the rejection issue of the implants. So then what we did in the study is that we did a structural characterization via NMR and other stuff also. And the big question is, will gallium act as a network former or a modifier in the glass? And in addition, we also studied the effect of crystallization. So we studied this bioceramics as well. And you can see the results at the poster presentation later if you're interested. Thank you very much.
Okay, this completes the official list for now. I saw that there were a few people arriving late, so even though most fire talks slightly exceeded the 1 minute mark, we're still in time. We have 15 more minutes. Should we just continue? I have 2 more presentations on this. 2 presentations I have on this jump drive, and maybe there's one or the other.
Let's do this too, because we have 15 minutes until the break, so let's go ahead.
Okay. I'm gonna you. Do you want first? Right. I'll just copy it to the. Just a second. Hi. No, perfect. I think we have time. If you want to leave it here, we'll just. No, I'll copy them first. Otherwise, it's going to be a whole back and forth. I'm going to leave this here. Hi, all right. Keep them coming. Both of those, right? Make a new talk. I'm just going to do it like this. Oops. Those are those. Yeah, keep them. Put them up here. Fala. Não apareceu aqui, putz, cara. Se você não tiver lá aqui agora no pendrive, tem só um segundinho. The first one. Aí não. Cadê a Laura? Você tem o mesmo problema? Você enviou online só. Putz, não tem alguém com computador onde vocês conseguem. Talvez vocês perguntam para a professora Ana Cândida aqui em laranja. Ela pode baixar os talks e põe no pendrive, porque acho que aqui não. Acho que tem acesso à internet. Yeah, okay. Let's see if I have the link. If I can find the link, I can probably get them here. But I just spontaneously ended up in this role, so I didn't prepare anything. How do I get the link then to the drive? That's the. Yeah, this froze. Okay.
Okay, so I've heard that a few of the presentations were uploaded, but they're not on our computer yet. Since the web browser is pretty frozen right now, I would say we continue with the talks we have physically here on the jump drives. I'll just check if I got the last one from. Did I copy this one? And then I got this one. Okay. So we continue with these for now. Okay, actually I have one more to copy. Leandro Olivetti, that one. Okay, so we have 6 more talks here right now. I would say we go on with them and then see how much time we have left. You want to use
Thank you. Hi, everyone. I'm Ecem Kırmak-Yamaç. I'm a PhD student at Alfred University of supervision of Dr. Colin Wilkinson. And today I'm going to start with our first project, testing the cohesive harmonic approximation in glass. This project includes two separate stage. The first stage is simulation, and the other stage is experimental one. Okay, we're going to start with vibrational density of states, and we want to use these properties for glass. We know that the quantized particles, we call that phonons, and phonons is very important when we think about the thermal properties of glass, such as heat capacity and thermal conductivity. And with this project, we want to prove that the phonon-phonon scattering modes are very important properties for heat capacity. So with computational way, we use molecular dynamics and lamps, and then we compare, yes. Sorry. I guess there is a problem. Okay. Sorry, there's a problem, but not important. Okay. In here, we saw that this is our simulation methods, and we use 5 different interatomic potentials, and then this is neutron scattering data from the experimental stage, and we compare our 5 interatomic potentials and the simulation one. So when we compare this, we want to prove that the vibrational properties is directly connected with heat capacity. So there's the animation, but not working, not problem. And then heat capacity analysis, and we want to compare with experimental stage and calculated one. Calculated one means with simulation, computational analysis, and when we compare these two one, do and Schick potential is best produce our properties. So our research going on with further analysis with machine learning methods, and then we compare our results with experimental data, and this project supported by Owens Corning, and thank you.
All right. I'll continue in the order. Okay. Let's do it in the order of the archives that are here. Then so where are you going to be last? That's Daniela.
Hello, everybody. My name is Daniela Jaramillo Raquejo. I'm from Colombia. I'm a physics engineer, but I'm doing my PhD just like 7 months ago. I started it. It's a co-tutel between the University of Friedrich Alexander University at Erlangen-Nuremberg and the University of Trenčín, which is in Slovakia. I'm part of this group of Foam Glass, Center for Functional and Surface Functionalized Glass. My project, I wanted to be the development of novel bones filler composites with enhanced bioactivity and biological response. It's basically produce a composite of cement, of a cement phase and a particle phase. This particle phase, in our groups, we have experience synthesizing mesoporous bioactive gas nanoparticles, but now, as they have been working with 3D printing, I would like in my project to start with this new approach, which will be an injectable product, which will be able to, through local injection of the mesoporous particles that might be loaded with proteins or drugs. For example, for applications of cancer treatment, if these particles are loaded with particles that have photothermal properties, and also as it is very important during or after the medical treatment that these void fields are also radiopass, they are radiopaque for the visualization and treatment. We have been, during these 7 months, reviewing the literature, and we would like to compare with these available injectable bone fillers, and also compare characterizing all the desirable characteristics with the 1 or 2 commercial ones. If you're interested in this work, or maybe you would like to collaborate, you are very welcome to my poster. Thank you very much. This is my contact information. Bye.
Hello everyone, and my name is Mansi. I am a student of Fun Glass, and this is my first year of PhD, and I'm working in the glass processing department. My supervisor is Dr. Joseph and Akansha. Also, I'm having a collaboration with Professor Arnico Bernardo, who is in University of Padova, Italy. My project focuses on upcycling of waste glasses. Basically, I'm going to use glass culettes, which are the recyclable glasses, waste glasses. And the aim is to prevent landfilling. The question is that, can these upcycled glasses be used for wastewater treatment? We are very well aware of the global challenge of treating wastewater due to obvious reasons. And a recent study shows that in the upcoming years, we will have this problem. One of the Indian city, Bangalore, has already been facing this issue recently, being a water-stressed area. And I'm going to use additive manufacturing for preparing the waste glasses. And it is a part of circular economy drive. I'm in my first year, and I'm projecting my group's recent research work, which is focusing on recycling pharmaceutical waste glasses by stereolithography, and they were dip coated by TiO2 layer, and you can see more about it in my poster. I'm very open to discuss about the visibly active photocatalyst for my work. And so this is my contact, and thank you.
Just a quick note, if you haven't presented yet and your talk is in the cloud, please talk to Lauri, who sits on that side of the room, so she can download the talk, put them on the jump drive, and we get to present them. Okay, I see some people going in that direction. Perfect. Okay. Do you want to go next? Yeah. Just a second. I think just arrow up and down.
Okay. Hi, my name is Vera Kerling. I just started my PhD at the University of Erlangen in Germany, and my topic is the effect of network formal addition on the crystallization and solubility of niobates, and I will study that in aluminosilicate glass matrix. The motivation is that you want these niobates as a crystal in perovskite structure because they have properties you need for energy conversion and energy storage applications. But they are very difficult to process as a ceramic, so you make a glass ceramic instead. And the goal is to have these niobates in perovskite structure in aluminosilicate glass. And this was already achieved. So you can see here a glass and the corresponding glass ceramic with niobates in aluminosilicate glass. But everything was great with this composition. The only problem was that the niobate solubility was very low. So in my work, I want to increase the niobate solubility by adding additional network formers in low amounts. And yeah, then I will study the influence. Thank you very much for your attention.
Acho que faltou. Tá.
Good morning, everyone. My name is Leandro Olivetti. I'm a master's student in chemistry here at the São Carlos Institute of Chemistry. And today I'm going to be showing some of my results entitled Structural Optical and Luminescent Investigation of New European Doped Niobium Fluorophosphate Glasses. So firstly, in a few words, we can say that we are studying how different niobium oxide content and different alkaline earth metals are affecting the resulting niobium fluorophosphate glass properties with all of these characterization techniques. And I'm going to be talking in more details during my poster's presentation, how we can see that the new niobium fluorophosphate glass showed great chemical and thermal stability against crystallization, how the niobium oxide content is related to the optical band gap, optical basicity, and matrix connectivity of the resulting glass. Also, when changing between different alkaline earth metals are related to the number of tetrahedral units isolated, the matrix connectivity, and also the symmetry of europium site. And that we can see that there's a periodical trend, allows tailored applications to new materials in this kind of resulting glasses. Thank you so much. I hope you all can pass by my poster's presentation, and thank you.
Well, I think we had an excellent overview of the research you guys are doing and ladies are doing. There's still 6 more talks, but we have to have a coffee break now because I have a contract with a company with serving coffee, and they don't wait too much. And in this life, we have to make decisions, as you probably know, and you guys have to make a decision now. Coffee break, or get your money, or hang your posters. So as you are a scientist, I think you'll find a way to do all of them at the same time. So you go downstairs, have your coffee break, hang your posters, come back here, get your money, and in the meantime, Laura will upload the 6 remaining talks, and we will continue a little bit this session here. Then we go back and have posters. How about that? It's a good planning, right? So, let's do it.
einfach zu spät. Die sind alle hier in diesem Firetalk 2 Ordner, aber lass mich die anderen mal zumachen. It's the same shit hier. Ist komplett aufgegangen.
Sind jetzt wirklich alle oder fehlt noch jemand?
Das sind die 1, 2, 3, 4, 5, 6, genau, das sind die 6. Aber warte mal, ich sag halt kurz Bescheid.
Mas agora é essa pessoa aqui, né? André. Certo. Pode deixar.
Vou chamar. Okay, everybody, we have 6 more talks, and then we will go back to the posters. But as I said, the posters will be hanging down there for 2.5 days, so there will be enough time for discussions and these kind of things. So I guess we will start with Andrea, please.
Good morning. So my name is Andrea Menezes. I'm chemical engineer. And in 2022, I got my master's degree in chemical engineering. But in that time, I was working at BMM, so I have had the honor to work with Professor Zanotto and to use the machine learning software developed by Professor Daniel Cassar, and Professor Zanotto. And the idea was to develop the niobium-containing optical glasses. And now I'm working at Mosaic Fertilizantes, and I'm in charge of the research and development of minerals, new minerals, besides the apatite and the fossil. And the idea now is to, the idea now is to produce new paintings with minerals for protecting agricultural and machinery in this industry. Thank you.
Daniela? Is not here? So, Garima?
Hello and a very good morning to everyone. My name is Garima Thakur and I am from India. And I am doing my PhD from Alexander Dubček University of Trenčín. And my partner institute is University of Padova, Italy. And I am working on investigation of viscous flow sintering of glass powder for the additive manufacturing applications. And I am doing my PhD under the supervision of Dr. Arish Dasan and Dr. Joseph Krexner from Slovakia University and Professor Enrico Bernardo from University of Padova, Italy. I want to elaborate my research project a little bit more, that I am using the waste glass powders to produce transparent glasses using viscous flow sintering method. And the successful results I will imply to the VAT photopolymerization 3D printing. So up till now, what I have done, that I have studied the effect of powder particle size on the transparency of glass parts. And I have also studied the sintering temperature required or necessary for shape retention. Because if I am producing a 3D printed part, and for some of the additive manufacturing method requires the post-processing, like debinding and sintering. And if I have produced 3D printed part, and I want to go to sintering, I want that 3D structure to be retained, not destroyed. So this is important, that what the sintering temperature should be, so that my shape of the green part or the final product is retained. And this is the method that I have used, which I will be discussing or explaining during my poster. And as you can see here, the particle size is contributing. The first one, as you can see, is more on the gray or black side, and the right one that you can see is more transparent or better one. So the particle size is affecting the transparency, I can say, and I will explain this result more during the poster presentation. And this is like hot stage microscopy, like at what temperature the shape is not destroyed and the proper shape is retained. So yes, this is my research topic, and thank you very much.
So, hello everyone. I'm Mathieu Chevreau, a first-year PhD student coming from Rennes in France, and I will talk to you about my PhD topic. So, I work mainly on the crystallization of chalcogenic glasses. So, first let me remind you what are chalcogenic glasses. So, they are made of chalcogenic elements. So, we use non-oxide. It's not this one. There was a little displacement, but it's sulfur, selenium, and telluride. So we consider non-oxide glasses. And by using these elements, we do not make visible transparent glasses. We make, as you can see, dark glasses. So they are useful for infrared transparency. As you can see, they are transparent in the near and medium infrared region, which is very useful for plenty of application in the thermal imagery. So with the context, let me dive into my subject. So I have two main axes of research. The first one is the most novel one, which is the complete crystallization of sulfur SB5S8 glass. So the goal is to make a glass whose composition matches the crystalline phase. So first you make the glass, and then you make it crystallize fully to obtain an infrared transparent ceramic. So this would be the goal, final goal. I have also a second axis, which is the synthesis and sintering of gallium selenide powder. So this is also a crystalline powder, which I sinter by spark plasma sintering. And we obtain pellets that are also transparent in the medium infrared region. So if you want to know more about this, feel free to come to see my poster. Thank you for your attention.
So, hello everyone. I am Rafael Abel de Silveira. I study at the Federal University of Rio Grande do Sul with Professor Silvio Buchner. And I mainly focus on the high pressure effects on a glass. So, something we did lately was to use a diamond navel cell on the synchrotron laboratory here in Brazil, where we used a glass. And in a diamond navel cell, you put the sample in between two diamonds and you basically press them so you can have in situ measurements. And in this example, we had the X-ray diffraction of the glass up to 30 GPa. And in here, we can identify a distinct amorphous phase that happens because of pressure. And something else we did on the same study was obtain the Raman spectra, where we can observe the QN species and how they evolve with pressure, and also the intertetrahedral bond angle between the silica species, where we identify some discontinuities which are usually related to the elastic limit or also because of the distinct amorphous phase. And some more details, I invite you to come to my poster and we can discuss this work. Thank you.
Thank you.
Good morning. Hi, I am a PhD student at URGS. My professor is Naira Balzaretti. So my research is on the effects of right pressure on lithium silicate matrices doped with rare earths. The objective of my work is to improve the efficiency of solar cells by incorporating rare earths and high pressure into lithium silicate matrices. So I am at the stages of producing the matrices. I'm producing two rods. I'm using two rods, fusion and sol gel. Thank you.
So is Daniela here? Daniela Jaramillo? Okay. Okay. So that's it. Yeah.
Hello? Oh. So, okay, now we have, what time is it now? Let me check. 10:40. So we have about 1 hour and 20 minutes to check the posters. So let's go downstairs and check the posters. Eu vou dar umas instruções e te chamo. So we'll move down to check the posters, and then at about 12ish or so, please get some of the locals who are, raise your hands, those who live in São Carlos, who can guide. You can guide people. You do not live here, but you can guide people. See, these guys, with their hands on, please pick one of these ladies or guys. They can lead you to the best restaurants, you know, the best restaurants. There are several restaurants, but some are better than others. And also, very important, whatever you do, be back, please. Let's say 10 to 2 here. So Professor Helmut Eckert, which is very, very well known worldwide, will give his talk here. And he is a little bit injured. He made a lot of effort to come here. So please be here by 10 or 15 to 2 back here in this theater. And, I guess you need some money. The students need some money for lunch and everything else. So Laurie, just now we'll be giving your envelopes. She'll give a piece of paper. You have to sign and give some information, address, etc., for our sponsors who are responsible for these per diems you're going to get. So you have to fill up a piece of paper. So Laurie, maybe you can give this piece of paper. Let me get this paper so you can. Only the students, only those who are getting some per diems. Laurie will give for those who traveled, who need the per diems, you need to sign a piece of paper. And now, I think, while you do this, Daniel, our young professor, Daniel, my collaborator, volunteered to give some instructions on how you should give a fire talk, right? So, okay. Thank you, Professor. Sorry for the intrusion in that way. I'll try to be quick, as a fire talk should, but when I was looking at the talks, I remember when I was in your position doing those, and I always felt like no one never, or usually don't talk to us about how we should do this. So I decided to quickly say something that might lighten you, and then again, you can talk to me if you want to know something else about it. My suggestion is for you to always think of a fire talk such as the trailer of a movie. So in the trailer, you don't really see everything that the movie's got, you know, like all the conclusion of the movie. You leave that for when you actually see the movie, or when you go talk to the researcher. So I would say the idea of a fire talk is for you to tell people why you are trying to achieve what you are trying to achieve, or why you are doing what you are doing, right? So after you do that, you might show some qualitative, not quantitative, but qualitative results. So I did manage to solve this problem by, I don't know, merging this technique with that technique or whatever. And we did get some good results. That's overall that. And if you want to know how I did it and specifically what are the results, you look for me, you know. I see that most of us want to show everyone like, we did our work, we're working a lot. So you want to put a lot of results, a lot of graphics. There's no point on it. In like 1 minute or 2 minutes, you cannot see all these graphs. You don't have time to look at it. And if you are talking about what you did, you don't really need most of the information you put there, especially if it's written on text. So try to avoid text as well. So, yeah, be minimalistic, be simple, get people curious about what you are doing, and then let them come to you so you can explain the details. I think a lot of you said that, but you didn't do it on the presentation, you know, in that way. So that's it. Okay. Okay. So now, fill up the paper, get your money, and go downstairs, please, for the poster section. Laurie is, where is she? Oh, she's giving. Let me help you, Laurie.
So, if you need some help to fill this, because this is in Portuguese, this is like how much you receive, right? Okay. So, you should put your name, and then the document identification. Endereço means address. Number, okay, where? Okay, and the complemento is just don't need that. Cidade is your city. Bairro is neighborhood, but probably is not for you. Estado is your state, or you can put your country. Roteiro de viagem, precisa? Roteiro de viagem é a hora da chegada do que é isso? So, roteiro de viagem means your travel. So, is the date. This is the Quando saiu de lá, quando chegou aqui?
Saiu de lá, chegou em São Carlos. Saiu de São Carlos, chegou lá.
So, the roteiro de viagem, it means when you leave your country, and then chegada means when you arrive here, and then saída, the next line will be when you will leave here, and the next one is when you will arrive in your country. And the last things I think you don't need to fill. And sign in the end. And local and date should be like São Carlos and today. 22 April, that's it.
Obreira, será que tem algum cabo que dê aqui?
Não quer colocar. Não está com pendrive, professor?
Oi?
Não está com pendrive? A senhora não tem pendrive? Porque esse notebook eles estão usando para isso. Ixi. Quer testar uma outra tomada? É qual é esse daqui?
Já testei 3 tomadas. Será que o adaptador está com algum problema? Esse é o do Helmut. Se tirar, ele não entra ali, né? Ele é muito grosso esse fio. Entra?
Outra tomada aqui, ó.
Legal. E como que é o almoço? Cada um por si? Né?
Eu preciso
Vê
só...
se eu compro alguma coisa e trago aí pro Helmut. Porque você sabe que ele
O que aconteceu? Caiu lá?
caiu. No sábado à tarde. Ele embarcar no sábado.
Esse final de semana ainda?
No sábado à tarde ele me liga. Tô com uma emergência aqui. Pelo amor de Deus. Ele estava em Frankfurt, eu estava em Berlim. Acho que eu não vou conseguir viajar. Não, pelo amor de Deus, vai pro hospital. Aí ele falou, vamos ver se eu consigo viajar. Assim, vai pro hospital. Faz um raio-x. Aí fez o raio-x, viu que não tinha quebrado nada, aí deram o quarto de dinheiro pra ele. Ele pegou o táxi e foi no
aeroporto.
Aí ele estava na casa da tia, uma escola de jardim.
Eu acho que deve ser. Nem ligou, né?
Não.
Mas tá vendo que não tá frouxo?
Também tentou em todas as outras tomadas. Eu coloquei até aqui embaixo.
Então, eu coloquei.
Eu tô achando que é o carregador.
Vai tocar por ele, viu?
Não, não vai tocar. Deixa eu ver se o meu.
É esse coisa aqui, ó. Não, será que tem algum desse?
Deixa eu ver se dá aí.
Tá
no
C, né?
que eu tô usando lá.
Eu vou me procurar aqui.
Nossa, parece.
É.
Esqueci o negócio. Não tem aqui.
O que eu tô usando é de fino, professora. Não vai rolar.
Deixa eu tentar o carregador do meu celular.
Eu pensei nisso também. Se não der, o meu tá no carro. Deve estar com o meu contato esse negocinho.
Eu esqueci o meu cabo na casa da minha mãe. Aí eu pedi pro Helmut emprestar. Só que não tá funcionando.
Mas a apresentação em si tá onde? No computador? Mas não fez nenhum backup no drive, nada assim, de repente.
É mole?
Acho muito difícil.
Mais ou menos 70?
Hoje 75, agora de manhã tinha 75.
Ah, é?
Mas tá completo, porque tem pouco crachá ali. Deu?
Ligou?
Cara, você deu uma luz.